Now we'll solve some problems using the formulas of friction and conservation of moment. The first question is a body of mass 5 kg is moving towards the north with a velocity of 4 meter per second. Suppose this is a body which has 5 kg mass and it goes, suppose this is the north side, suppose this is the north side body with 4 meter per second and the velocity is 4 meter per second. Another body of mass 3 kg is moving south with a velocity of 2 meter per second. So as this come from north and another body is coming from south, suppose this is the south side, as north and south are opposites, so this is the south part and the mass of the body is 3 kg and the velocity is 2 meter per second. At a particular time the bodies collided and become a single body, so it become a single body. At what velocity and which direction the combined body will move? So for this solution, to solve this problem, we know as if we take the north side as positive, the automatically the south side will be negative for velocity, because velocity is an vector quantity. And if I take north side as positive quantity or positive quantity, then automatically the velocity of left side will be negative. We discussed this thing in our previous lectures. Now we know for this kind of situation the formula is m1 u1 minus m2 u2 equals to v into m1 plus m2. Here m1 equals to 5 kg, m2 equals to 3 kg, u1 equals to 4 meter per second, u2 equals to, as this is positive, that will automatically will be negative, so this is equals to 2 meter per second. We have to find out the velocity of this single body and the direction of this combined body. So on the direction of this combined body, so first of all we just calculate the velocity of this body. So for v we can write v equals to m1 u1 minus m2 u2 divided by m1 plus m2. And here we can get for m1 we can write m1 as 5, u1 as 4 minus m2 as 3 and u2 as 2. As this minus we actually represent in this formula, so we don't need to again write this thing in the formula. And for m1 we can write this is 5 kg and 3 kg, so this is divided 5 plus 3. So the whole equations will be, if I solve the whole for equation, we will get v will be 1.75 meter per second, and this is the positive side. We found this value as positive, and we know when this kind of scenario happen, if the answer is positive, then the body will move in the positive direction. If the answer is negative, the combined body will be moved in the negative direction. So as the value is positive and the north side we calculate the north side as positive, then we can write the combined body will move towards the north with a velocity of of 1.75 meter per second. So this is the answer of our first problem. Remember this thing, as I use the minus sign in the formula, so I don't need to use the minus sign here. The actual formula of conservation of momentum is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. This is the actual formula for conservation of momentum. Here it means that total conservation before collision equals to the total conservation after total momentum after collision. Total momentum before collision equals to total momentum after collision. Total momentum before collision equals to the total momentum after collision. This is the formula of conservation of momentum. So we solve another problem. Now coming to the next problem. The next problem says that a box of mass 70 kg is pulled by a horizontal force of 50 Newton. So this is the box with the mass of 70 kg, and it is pulled by an horizontal force 500 Newton on the surface of the floor. So this is the surface of the floor. The coefficient friction between the floor and the box is 0.50. So we have to calculate the acceleration of the box. We have to calculate the acceleration of the box. So how we have to calculate this thing? Here we find out the coefficient of the friction, and this is the coefficient of kinetic friction because body is moving on the surface. So this friction is known as coefficient of kinetic friction, and we find out for solution you can write the coefficient of kinetic friction is mu of k. We represent this as mu of k. We find out this coefficient as 0.50, and the mass of this box is 70 kg. 70 kg. So the weight will be mg. So weight will be mg. Mg equals to m into 70 into 9.8. 70 into 9.8 equals to 686 Newton. 686 Newton. And we know this W and the reacted force is always equal. So this is the normal reaction, and this is the weight. So these two are equal. So and the horizontal force we applied, the horizontal force is 500 Newton. So we represent this as F equals to 500 Newton. So now we know for frictional force we know mu of k equals to F of k by R. F of k by R. So here the frictional force k equals to mu of k into R, and we know the mu of k equals to 0.50 and R is equals to 686 Newton. So the total is 343 Newton. This is the frictional force, and this is the applied force. So the resultant force applied in this body, so actually if I this is our frictional applied force, and this is our, what should I say, this is the frictional force, and both are in the opposite side. So the resultant force, if I say that the actual force that is applied to this box is, if I say that is F prime, if it is F prime, so we can write F prime equals to F minus F of k, and we know the F equals to 500 Newton and the frictional force is 343 Newton. So if we calculate this thing, we will get 157 Newton. So the box is moving with the force of 157 Newton. So now we have to calculate the acceleration of this box. So for calculating acceleration, give me some time. We know according to Newton's second law, F equals to ma. Here F equals to F prime. So A equals to F prime by m, and we find out F prime equals to 157 Newton, and m equals to, we know the mass of the box is 70 kg. 70 kg. So the answer will be 2.24 meter per second square. 2.24 meter per second square. So this is our second problem we solved. Now coming to the last problem. Last problem is a problem of motion of rocket. So it says that a rocket while moving upwards loses 1/50th part of its mass in the first 2 seconds. In the first 2 seconds, it loses the 1/50th part of the mass of the 1/50th part of its mass. So we have to find out if the velocity of the ejected gas is 2500 meter per second. So we have to find out the acceleration of the rocket. So acceleration of the rocket. So we know for finding out the acceleration of the rocket, the equation is A equals to 1 by m into del m by del t into v minus g. Here, suppose let the mass of the rocket is capital M. This capital M represents the mass of the rocket. Del m by del t represent the rate of change of gas ejection or burning the gas, the rate of change of burning the gas. And here v equals to, so first of all, if I write v first, then it will be easy to calculate. V equals to 2500 meter per second, the ejection of gas, and its constant value. So first of all, we have to find out this term del m by del t. To find out this del m by del t, we have some information that while moving the upwards, it loses the 1/50th part of its mass in the first 2 seconds. So there the del t equals to, if I take del t equals to 2 seconds, and del m equals to the in this 2 seconds, it loses 1/50th part of its mass. So the total mass is m, and this 2 seconds, the rate of change of this mass is 1/50th part of this m. So we find out this m by 50. M by 50. So now if we put all this value in this section, we'll get 1 by m into this del m by del t equals to m by 50, and for this del t we'll have 2 seconds. This as del t equals to 2 seconds, del m equals to 1 m by 50, and this del t equals to 2 seconds, and this v equals to 2500 meter per second, and the value of g is, we know the value of g is 9.8 meter per second square. So this m and m will be crossing over. If I cutting this thing also, I will get 50, and this is actually 25 minus 9.8, so 25 minus 9.8 meter per second square. If we calculate this whole term, we will get 15.2 meter per second square. So this is the acceleration of the rocket. So we solve different types of problem of this chapter, and we saw how we can solve this problem in different way. I hope you understand all of the concept of this chapter, laws of motion, and understand how we can solve mathematical problem using the formula we have generated. Please like this video and do subscribe to our channel. Thank you.